Hi, my name is Dan, and this video is part of a short series of videos on registers, which is part of a much larger set of videos about digital electronics, which goes in a grand scheme from basic logic gates all the way through to creation of a simple 4-bit CPU, just a computer core. So there's a roadmap of where we're going in the description down below, and also a link to the software that I've been using to do simulation of the electronics hardware called DigitalWorks. So a link to that will be in the description below as well. So far we've been building up some of the fundamental uh, little circuits, logic circuits that are of incredible use within computing. And with this short series on registers, we're starting to look at some specific components that go into use in CPUs. So let's kick off this series with a bit of a discussion about registers and what registers are. So computers use numbers. I think we all kind of instinctively know this. There are three kinds of fundamental kinds of numbers that are being used by computers. So instructions, telling the computer what to do, how to process things, they're numbers. Memory addresses, and we'll touch on those a little bit later in this video, are also numbers. And data is numbers, and data can mean all sorts of things. Obviously, a fundamental principle, they're numbers, but things like text is numbers, and pictures are numbers, and video is numbers, and sound is numbers, or it is when it's being used by a computer. For a computer to manipulate anything, it has to turn it into numbers. These numbers are binary numbers that are being used by the computer. So CPUs need to be able to remember numbers internally. They need to have several of these in mind at once for various different purposes. So we use things internally in CPUs called registers. So what is a register? It's memory. It's holds a single register holds a single binary number, which is usually called a byte. So when you hear about CPUs being of a different number of bits, and in this series of videos, we're creating a 4-bit CPU, which is very limited. Some of the earliest ones were actually 8-bit. Windows operating systems and computers use 64-bit. Consoles are starting to use 256-bit and bigger. This number of bits describes how big your registers generally are, and and other aspects of your CPU as well. So CPUs have several of these things built in, uh, usually. So most of them have specific purposes. So the current instruction that's being carried out on the CPU, that'll be held in a specific register. Addresses to find data in a memory bank. The specific registers for that. And data, there are registers that are there just to hold data for manipulation. Some registers are general purpose registers and are there just to allow you to shuffle numbers around. But mostly they can be thought of usually as data data registers. So computers use numbers, as I've been saying. The CPU knows the meaning of a number by which register it's stored in. So not all registers are the same in terms of how they're connected to other components, and certainly in terms of how they're interpreted by the CPU. And the numbers themselves don't need to have any kind of extra information to say what kind of number it is. The CPU knows what kind of number it is by which register it is being held in. So I'm going to do a quick comparison of registers and memory with registers are memory, of course, but we also have this concept of the memory bank, and I've mentioned this CPUs also do need larger memory stores, which are lots of bytes, not one byte at a time. And these memory stores hold the program and the data that is currently being run by the computer. Registers are small and fast, and physically they're usually very, very close to the other components on the CPU. This increases their speed and their use, but the compromise on that is that they need to be small because they obviously actually take up space. Memory banks are bigger and slower is a relative term because memory is in fact still incredibly fast. It's just not as fast as the registers. Generally in the use of these things, registers change value very, very fast and very often. Memory banks tend to hold data for longer periods of time. Again, we might be talking in some cases only for a few clock cycles, but in some cases for the duration of the program. Um, you'll have that stored in the memory. Memory needs addresses, so because there's a lot more of it, when you're accessing the memory from the CPU, you need to know which precise element inside the memory bank you're accessing. And so, as well as the data that's stored in a memory bank, there's also this concept of an address, which again is a binary number. And I said earlier in this video that one of the forms of numbers that are used in CPUs is memory addresses. And in contrast to that, registers don't have addresses. They have names, which are used in terms of thinking about them and designing them. But the CPU itself doesn't need to know the names because they are wired specifically in such a way that they're useful for the particular uses that those numbers are going to be used for. So the wiring of registers, apart from general purpose registers, tends to be quite specific to the purposes of the registers. So that's a general introduction to what a register is. Over the next few videos, we're going to go for a bit more discussion, an introduction to a new kind of logic gate that we haven't seen before in this series, and then finally an implementation of a register using the digital work software. But that's it from me for now.